Welcome to the 10th lesson in my CSEC mathematics series for the topic of measurement. In this lesson, we'll learn about the margin of error in measurements, and by the end of the lesson, you should be able to understand what it is, why it matters, and how to calculate it. Now, let's first start by answering the question, what is a measurement error? Measurement errors are an unavoidable part of any measurement process and can arise from various sources. By understanding these sources of error, we can work to reduce them and improve the accuracy of our measurements. In this lesson, however, we'll focus specifically on measurement error associated with the limitations of the measuring device. To understand more about the error associated with a measurement, we need to understand the margin of error. The margin of error reflects the precision of a measuring instrument. For analog scales, the margin of error is based on the smallest scale division. In this diagram, it is represented by this green and yellow line. By dividing the smallest division by 2, we account for the uncertainty that arises when estimating a value between two marks. For digital scales, the margin of error is typically plus or minus 1 of the last displayed digit, which reflects the uncertainty in the least significant digit shown by the instrument. In this case, it will be plus or minus 0.01 as the smallest measurement. Let's look at a couple of examples. Determine the smallest unit and margin of error for a standard ruler with millimeter markings. Let's look at example 2. A kitchen scale has a digital display that shows the mass of items to the nearest 0.1 grams. What is the margin of error? Now we can use this margin of error to establish a range within which the true value lies. It is found simply by taking the measured value and adding the margin of error, and taking the measured value and minusing the margin of error. This will give you the maximum value of the range and the minimum value of the range. Let's try this example 3. A measuring tape has markings every 0.5 centimeters. A rectangle is measured as 11.5 centimeters. What is the maximum and minimum measurements? Let's look at example 4. A digital thermometer displays temperature to the nearest 0.1 degrees Celsius. If it reads 36.7 degrees Celsius, what is the maximum and minimum measurement? Let's look at this final example 5. The length of a room is 5.0 meters. The smallest measurement on the measuring tape used was 1 millimeter. What is the range within which the actual measurement lies? In this lesson, we covered some concepts about measurement accuracy. We started by defining what measurement error is and why this error is unavoidable. Then we looked at how to determine the margin of error for an instrument, and we used that margin of error to determine the range within which the true measurement lies. Thank you for joining me in this lesson on margins of error. In the next lesson, we'll look at scaled diagrams. Feel free to leave any questions or comments below, and don't forget to join the Google Classroom for the series resources. See you in the next lesson. Bye.